Alright, what I'd like to do is give you guys another example of some coterminal angles and how to show them. First thing we need to remember about coterminal angles is coterminal angles are angles that have the same initial and same terminal side. So I'm going to work with this in degrees and I'm going to work with this in radians because we have to start getting out of our head always thinking in degrees and begin to start looking into radians. So initially what I need to do is I'm going to find a couple more angles that are between that have the same initial and terminal side, which I've written down in these three graphs. Now, automatically, if I could say, well, my first angle is from here and this initial side to the terminal side, my next angle could be from there to there. And we say, well, how do we figure out what that angle is? Because obviously, if I know that's 30 degrees, I can do my math in my head pretty easily and say, well, that's negative 330. But how am I going to do that with my radians? Or how am I going to do this mathematically if I get a tougher problem? And what we can do is, if you say, you take your radian, or you take your angle, and if it's positive, you subtract 360 degrees. That same goes for when you have it in radians. Pi over 6 minus 360 degrees in radians is 2 pi. The difficulty with this is, now you have to go ahead and work with fractions. So we have to go back and have some flashbacks from our early algebra days and multiplying by fractions. So since they don't have the same denominators, I have to multiply by 6 over 6. So I get pi over 6 minus 12 over 6, which equals a negative 5 over 6. Now, one real quick thing just to know is, well, how do you know that negative 5 over 6 is right there? Real quick, guys, I'm going to keep on referring to this in a lot of my videos. If I was going to quickly go over this, and I was going to say, I know that this is 2 pi, this is pi, and this is pi over 2. That's 3 pi over 2. But if I'm using now a denominator of 6, I know that this is going to be 12 over 6, this would be 6 over 6, and this would be 3 over 6. So if that was 3 over 6, and that's, or 0 over 6. But if I'm working, it's also 0 pi as well. But if you guys if you're looking at, if this is 3 over 6, well, I get to 6 over 6, that means I'm going to have a 4 over 6 and a 5 over 6. So now what I'm looking at, this is a negative 5 over 6. So therefore, going in the negative direction, how do I do it? That's a negative 11. I'm retarded. Where did I get 6? That's a negative. Why did nobody call me out on the 5? That's a negative 11. So anyway, still, I know that from here to here is going to be 6 over 6. And then if you look over here, I'm 1/6 away from 12. So I know my negative 11 is going to be right in that area, which is exactly this graph as well. So there is two coterminal angles. Now these two coterminal angles, 30 degrees and negative 330 degrees, are between our there's nothing greater than 360 degrees. However, what we can also do is, you notice, if I want to find another coterminal angle, I can go above 360 degrees and just add another 360 or add another 2 pi, and I can say that 390 degrees, that's also a coterminal angle. Because all I'm doing is I'm going around once, and then I'm adding an extra 30 degrees to go get another coterminal angle. And the same could be true about going the other way. You could also go negative, that's negative 330, and you could go ahead and add another 360 in the negative direction. Okay, so negative 330 plus a negative 360, because remember, going in that exact same direction is going to be a negative 690. So those are all coterminal angles. And the reason why I show you guys these multiple ones, a lot of times in your problems you'll get you'll get angles that are greater than 360 degrees. So if you need to find your angles that are between 0 and 360, you're going to have to subtract away your 2 pi or your 360 degrees to get them between 0 and 360. Okay? All right, that is how you determine coterminal angles.